Yes, Siddharth ji, I am audible.
Hello.
Yes, I am audible.
Yes, sir. You are audible. Sir, my voice is coming?
Yes, coming.
Okay.
Yes, सिद्धार्थ जी। अभी हम बात करेंगे HPPSC की। यस।
Yes, sir.
HPPSC में क्या है कि जो इंटरव्यू है वो टोटल इंटरव्यू बेस्ड है ना। कितने मार्क्स का इंटरव्यू है ये आपको पता है?
100, sir.
यस। अब टोटल 100 मार्क्स पे ही डिपेंड है, क्योंकि वो स्केलिंग था तो वो स्केलिंग क्लियर हो चुका है जितने लोगों का है। 108 इक्विवेलेंट 37 वैकेंसी। यस।
Sir.
तो देखिए, जो मैं मॉक अभी तक कराए हैं मैंने, जैसे यूपी पीजीटी, यूपी एचएससी, आरपीएससी, सो मेनी एग्जाम्स होते हैं। इसमें क्या होता है, पहले तो बेसिक इंट्रो। आपने इससे पहले असिस्टेंट प्रोफेसर का इंटरव्यू दिया है कोई?
हाँ सर, मैंने मतलब दिल्ली यूनिवर्सिटी में दिए असिस्टेंट प्रोफेसर के। बाकी तो यूपीएससी जीएसआई वाला दिया है।
या जीएसआई
और
वाला?
अभी फिटजी का दिया था। फिटजी में जैसे इंटरव्यू था,
यस
तो
यस।
लेक्चर इंटरव्यू वो दिया था।
फिर जी में यस, लेक्चर पढ़ाने के लिए। यस यस। ड्यू में आपने दिया था, तो ड्यू में उन्होंने टॉपिक के अकॉर्डिंग आपसे टीचिंग कराई थी, मतलब कि बेसिक
नहीं
डायरेक्ट
टीचिंग,
रैंडम?
नहीं सर, टीचिंग नहीं कराई थी, सिर्फ क्वेश्चंस थे। मीन्स वो
रैंडम।
कुछ जो टॉपिक्स पे क्वेश्चंस पूछ रहे थे और उनके आंसर्स थे।
यस, वो रैंडम वाला लिया था। जीएसआई में रैंडम होता है, जीएसआई में टॉपिक पूछा ही नहीं जाता।
नहीं सर, जीएसआई में नहीं पूछा।
तो जीएसआई का तो रैंडम है। तो देखो यहाँ पे क्या है, जैसे बीपीएससी के अभी इंटरव्यू 18 से है, तो उनके मॉक में ले ही रहा हूँ। तो इसमें क्या है कि ये होता है कि पहले तो बेसिक इंट्रो आप अपना स्ट्रॉन्ग कर लीजिए। बैकग्राउंड आपका है, नेम, फादर्स नेम, और 10th से लेके पीजी तक। और जो भी गैप है तो गैप को मेंशन कीजिए क्या किया है। उसके बाद आपने अगर नेट गेट क्वालिफाइड है या और भी चीज़ें क्वालिफाइड है, जो भी अचीवमेंट है वो आप ऐड कर सकते हैं। ठीक है ना। और मॉक में क्या है, मॉक उस बेस पे होता है, जैसे व्हाट्स योर फेवरेट पार्ट इन केमिस्ट्री?
My favorite part, like I like inorganic chemistry, especially coordination chemistry.
यस, इनऑर्गेनिक। इनऑर्गेनिक में आपका है कोऑर्डिनेशन।
Yes, sir.
और एनी अदर? ओनली वन?
No, no. Like in physical chemistry, I like chemical kinetics, and in organic chemistry, I like reaction mechanisms.
Kinetics and organic reaction. Okay, yes, very good topic for mock. तो ऑन व्हाट 26 अप्रैल से स्टार्ट है
Yes, sir.
मॉक एचपीपीएससी के रियल इंटरव्यू। तो आपको क्या करना है, मैं आपको अभी तो मैं थोड़ा बता देता हूँ बेसिक। एक तो इंट्रो आपका स्ट्रांग होना चाहिए, अभी मैं लूंगा आपका। ठीक है। एक इंट्रो हो गया और एक मॉक हो गया। मॉक आपने मुझे 3 बता दिए हैं। इनऑर्गेनिक में कोऑर्डिनेशन है आपका, फिजिकल में केमिकल काइनेटिक्स है, ऑर्गेनिक में रिएक्शन मैकेनिज्म है। अब ये 3 टॉपिक आपको स्ट्रांग करने हैं ऑन टीचिंग। टीचिंग के बेस पे आपके पास व्हाइट बोर्ड है?
No, sir. I don't have any whiteboard at home.
यस, कोई प्रॉब्लम नहीं है। तो फर्स्ट ऑफ ऑल हम बेसिक से स्टार्ट करते हैं। टेल मी समथिंग अबाउट यू।
Okay. Good morning, sir. Good afternoon. Sorry. Good evening, sir. My name is Siddharth-CHEM, and I have done my education from 10th class from senior secondary school St. Anselm, and 12th also I completed from there only. Then I gave the exam and I went to the Central University of Rajasthan. From there I did my BSc, and after that I qualified IIT-JEM exam, and I went to the Institute of Science for doing my MS. And from there I did my MS, and after that I have qualified the NET and GATE in year 2021, and recently I am appearing for the interview.
MS from?
Indian Institute of Science, Bangalore.
After that, you have qualified so many exams, yes?
Yes, sir.
What's your hobby?
Oh, so I like to play badminton and like to watch movies. And in my free time, I would like to learn some new technologies if it's regarding my subject, if they are.
Badminton. Yes. What do you feel about badminton in India?
What, sir?
What do you feel about badminton?
Okay. Sir, badminton is a good sport, and nowadays means from the past few years we are seeing the increase of means craze about the badminton, especially after the India got medals in the Olympics, especially by the PV Sindhu, as we can see in the recent last two Olympics, she won bronze and silver medal. So I think it's increasing, and also it's a good sport for maintaining your health and mind, because if you play at least 1 hour, then it keeps you afresh the whole day.
Yes, good. Are you from Rajasthan? Yes.
Yes, sir.
How do you feel about Rajasthan?
Sir, Rajasthan is a good place to stay,
Yes.
especially means it is having extreme climates also and moderate climates also. So you can feel cold, heat, and everything there. So it's a good place to stay.
How many districts in Rajasthan?
Sir, previously there were 29 districts, but recently 19 new districts have been more announced. So now there will be 47 districts.
47 or 52?
Sorry, 52. Sorry, 52 districts. Yes, sir. 1933 and 1952 districts.
Yes.
52 districts.
Who is education minister in Rajasthan?
Dot, Dotasra. Sir, I don't remember right now. Yes.
I think BD Kalia, I think.
Means I don't remember. Right.
And central education minister? Who is central education minister?
But I don't know that.
Uh, how do you feel about Himachal Pradesh?
Sir, Himachal Pradesh is a good place, especially means I visited after a long time. Means I came to Himachal Pradesh when I was very young, especially for visiting Kullu, Manali and all. But recently when I came, I felt that okay, it's a good place and a beautiful city like Shimla for staying. So I feel it's amazing experience.
Yes, good. Why will you become a assistant professor in HPPSC?
So there are two reasons for that. First thing that it's means like I want to stay in Himachal because it's a beautiful city. It's a beautiful state, and also I can means explore the things which I was not able to explore during my means learning education means during my education. Like I can visit many places in Himachal which are very beautiful, which we want to visit every time. And second thing was that means Himachal Pradesh is having a good means culture of education, especially they are providing strong educations to the persons that is not seen in many states. So I would like to become assistant professor in HPPSC.
Yes, good. Yes, we have to discuss about mock.
Okay.
Yes. So first of all, uh, inorganic. Inorganic means what is chemistry? First of all, basic question.
Okay. chemistry is basically the study about the things that are happening around us. Means like if any reaction is happening, if any changes are occurring. So what are the things, especially the parameters that are causing those changes? So studying of those changes is basically chemistry. In general terms, we can define.
Yes, good. What is the difference between inorganic, organic, and physical chemistry?
Okay. Sir, inorganic chemistry basically deals with the ions and metals. And in organic chemistry, we are having the organic parts like carbon, nitrogen, oxygen, and the rest other are elements are there in inorganic chemistry. While the physical chemistry deals with the physical parameters that are surrounding the inorganic and organic chemistry, we can say broadly.
Yes, good. What is coordination chemistry?
Coordination chemistry is a chemistry which deals with the study of the coordination complexes. Coordination complexes are the molecules which are formed by the formation of the coordinate bond. Coordinate bond is a special type of bond which is formed by sharing of two electrons from one species, which is called a donor species, to the other species, which is an acceptor species. So it's not a sharing of electrons, it's just a donation from one species to another species. So study of these type of complexes is called as coordination chemistry.
Yes, good. What is coordination compound?
Okay, sir, coordination compound is the compound formed when the donor species donates its electrons to the acceptor species. Especially in case of acceptor species, we are having metals, and in case of donor species, we call them as ligands. So the complete compound which is formed by the donation or acceptance of the electrons is called as coordination compound, which is found between the metal and the ligand. And we write it in a square brackets by denotation.
Any example of coordination compound?
So there are many examples like K3FeCN6. We can say it's K4FeCN6 also, cobaltamine, hexamine complex. So there are many examples.
Yes. Who's father of coordination chemistry?
Werner, sir.
So how do you feel about Werner theory?
Sorry, sir. Can you repeat?
How do you feel about Werner theory?
Okay. Sir, Werner theory was given by the Werner to explain the coordination compounds, and he explained the coordination compounds about their structure and valencies. So he gave 3-4 points. First one was that every compound has every metal ion has two types of valencies. One is primary valency and secondary valencies. Then he gave the second point that the primary valencies are ionizable while the secondary valencies are non-ionizable. Third thing he gave that the primary valencies are non-directional. They do not determine the geometry of the complex, while the secondary valencies have their directional properties and they determine the geometry of the complex. So based on these things, he defined the complexes and explained about the coordination chemistry.
Yes, good. What is the difference between primary and secondary valency?
Okay. So, like primary valency is an ionizable valency. When we put the coordination compound in the solvent, the primary valencies get separated and they constitute into the different ions, while the secondary valencies are non-ionizable. We can't separate the ligands associated with the secondary valency from the metal. And second thing, the primary valencies are non-directional. They do not determine the geometry of the complex, while the secondary valencies are directional. So they determine the geometry of the complex.
Yes, good. Any limitation of Werner theory?
Yes, sir. There are many limitations. First thing was that he was not able to explain the different type of colors that were occurring in the complexes. Second thing, he was not able to explain the stability, why the complexes are stable. Third thing, he was not able to explain their electronic and magnetic properties, which are shown by the coordination complexes. And fourth thing, he was not able to explain the spectra of the complexes. So these are some limitations of it.
Yes, good. The other is, what is the difference between ENA rule and 18 lockdowns rules?
Okay, sir, ENA rule is basically effective atomic number as defined, and it defines the most stable configuration of the metal or the coordination complex that is achieved by the metal ion. like if the metal is having 3D series, then the maximum electrons it can have to attain the stability is 36. So we define that as an effective atomic number of the metal ion, that if it has having 36 electrons in the complete coordination sphere, then it is a stable molecule. While the 18 electron rule is defined basically based on the theory that, okay, so based on the theory of the transition metals, like the transition metals are having s, p, and d orbitals. So if for a series transition metal, if s, p, and d orbitals are filled, then if we comprise them completely, then we will have 18 electrons. So if a transition metal we have to look for, then we call it, okay, 18 electron rule, that they are stable when they are having 18 electrons. So there is no much difference, just it's an interpretation. Okay, effective atomic number is a higher version. Okay, it is having complete orbital spectra for every transition metal, but we are not having 18 electron rule for every transition metal. We can't follow, because when f orbitals come, the 18 electron rule fails when
Yes.
filling of f orbitals.
Yes, good. Any example of does not follow 18 and ENA rule?
Currently I don't remember it.
FeCN का O6 3 नेगेटिव. Yes, 17
FeCN
electrons.
FeCN6 3 negative. Okay, sir. Yes.
FeCN का O6 3 नेगेटिव. 17 electron system. And ENA is 35 and 18 is 17.
Yes, sir. Manganese cobalt complex, MnCO5. It's not following 18 electron rule.
Yes.
It has to get the 18 electron rule.
Yes. What is ligand?
Okay, so ligand is a basically donor species. It is having electrons which are present in the excess or which are available for the donation. Then ligand can comprise of ion, atom, or any molecule. Like ion, if it's Cl minus, atom, it can be like sulfur, oxygen also, and molecule like ammonia, H water we can have. So whatever the element that donates the electrons to the metal center, we call that as a ligand. And ligands can be of any type, like bidentate, tridentate, polydentate, ambidentate. So there are many different type of ligands.
Yes. What is ambidentate ligand?
So ambidentate ligands are those ligands which show, means which have two-way donor sides. Like it can donate from either side, but at a time it donates only from one side. Like HCN minus, it can donate from sulfur also and nitrogen also, but at a time when it forms bond, it donates either by sulfur or nitrogen. So those ligands which can show this behavior, they are called ambidentate.
Yes, good. Could explain. Next, move on coordination is isomerase. What is isomerase?
Sir, isomerism is a property which is shown by the molecules which are having the same formula, but they are having different in structure. And it can be like they are having different structure in 3D also, and they are having different structure in 2D also. So both type of things comprise of isomerism.
How many types of isomerase?
Sir, basically there are two type of isomerism. One is stereoisomerism and other is conformational isomerism. Like constitutional isomerism.
Isomerase first is two types, structural and stereo.
Structure, yeah, structural and stereoisomerism. And after that, in the structural isomerism, we are having different type of isomerisms, especially in coordination chemistry. They are chain isomerism, they are ionization isomerism, linkage isomerism, coordination entity isomerism, coordination position isomerism. And in the stereoisomerism, we can have the cis-trans isomerism and the optical isomerism.
Yes. And stereoisomerism is geometrical and optical. Yes. What is the difference between geometrical and optical?
Okay, so geometrical isomerism are having the different arrangement, like they can't be interchanged into one another just by rotation. They, for the interconversion, there needs to be a bond, needs to be broken. But optical isomerisms can be interconverted into one another. Like in enantiomers, we can see by the rotation, we can convert them into the one or the other form isomerisms.
Any example of geometrical and optical isomerism?
Yes, sir. Like if we take Ma2B4 complex, we can say if both the A, which are AR or unit dead ligands, so AA are on the same side and rest of the B are on the other sides, then it is cis form, and it's if AA are in opposite sides, we can say it as a transform. But if we take M means in bidentate ligand, which is having A configuration, then in the cis form it will show optical isomerism, and in trans form it will not show optical isomerism, because in cis form it will not have a superimposable mirror image. So these are the type of optical isomerism. But I can explain this better on if I have board is there, means by
Yes,
drawing.
yes. Next time you have to purchase, right? Next, move on. Next part in coordination chemistry is what is IPSC paddhati? Nomenclature. Yes.
IUPAC is a means institute or means International Union for Pure and Applied Chemistry,
Yes.
which basically provides the naming for the different type of coordination compounds, so that we can simplify the chemistry and we can name these compounds rather than just by predicting. So they define a particular set of rules by which we can name the coordinating compounds, and these are followed everywhere in the chemistry. These rules.
Yes. Good. What is the purpose of IPSC nomenclature in coordination chemistry?
To make the standard rules for naming. Otherwise, like if I name something for the compound and you name something else for that compound, so there can be a mismatch about the names. So IUPAC set a particular standards, and they have some rules, particular set of rules by which they can define the name of the coordination compound. So these are followed everywhere, and these are binding that okay, we have to follow these rules only for naming. So that's the main role of IUPAC.
Yes. Good. Next, move in metal ligand bonding in complex in coordination compound. Like theories, so many theories. Valence band theory, LFT, CFT. What is the difference?
Okay, so different type of theories tries to explain that the metal orbital and ligand orbital interactions, and basically the formation of the coordination complex, and explaining their stability and reactivity or their spectra, color, magnetisms, these type of properties of the coordination. But the best theory that has been given till now is the molecular orbital theory, and these are developed like first VBT was given, and based on the drawbacks of the VBT, CFT was developed, and it explains some properties, and based on the some drawbacks of the CFT, the molecular orbital theory was developed, and it is the best theory till now which has been developed for explanation of the coordination complexes.
Yes, valence band theory. Yes. Any limitation of VBT?
Okay, sir, there are 3-4 limitations. First limitation was that it was not able to explain the proper stability of the coordination complexes. Second thing, it was not able to explain the color that arises in the coordination complexes. Third thing, it was not able to explain the different spectral lines that were observed in the spectra of the coordination complexes. And fourth thing, it was not able to explain the proper magnetic behavior of the some coordination complexes, because from the theory we predicted it can be a dimagnetic complexes, but from the magnetic values we observed that these are the paramagnetic complexes. So it was not able to explain the magnetic properties.
Yes, this theory also failed to explain the bonding in electron deficient compound. Yes.
Is that bonding and electron deficient? Yes.
What is CFT?
Sir, CFT is crystal field theory, and it basically assumes the coordination bond to be ionic. like ligand metal is a positive center and the ligands are the negative center. And based on the ionic interpretation of the model, it defines the splitting of the orbitals in the coordination different means fields like octahedral field, tetrahedral field, and based on this, it explains the properties of the coordination complexes. CFT basically.
Yes. Any limitation of CFT?
Yes, sir. Well, first thing was that it was not able to predict why the ligand is behaving as a strong ligand or weak ligand. It just gave the spectrochemical series. It was not able to explain why this nature is seen in the ligands. Second thing was that it was not able to explain the like splitting of the again orbitals which are seen like in case of magnetic and electric field, like in Tenebron-Suno diagram and Orgel diagram. So CFT was not able to explain those splittings, why the splittings are there and why these transitions are seen. Third thing was that it assumed the nature of the bond to be purely ionic, but in reality, neither a bond is ionic and nor it's covalent. So it was basically on an assumption. So we can't say that it is having the correctness also, because then bonds can't be ionic and covalent both. It will have some ionic character and it will have some partial covalent character. So if we assume those, then the splitting and the energies that are predicted by the CFT are totally means not correct. There will be some difference in the splitting energies which are seen in the case of the diagrams.
Yes, good. Good explain. Next is, what is MOT?
Sir, MOT is a molecular orbital theory, and it basically assumes the bonds of the coordination complexes to be covalent, and it basically predicts the formation of the molecular orbitals from the atomic orbitals of the ligand and the metals. And the formation of the molecular orbitals is based on the linear combination of the atomic orbitals and then their combination with the metal orbitals. So based on their different energies, like we draw in the MO diagrams, and the splittings, it explains the different properties that are there in the coordination complexes.
Any limitation of MOT?
Sir, I don't remember right now. And we never have a chance to study these type of limitations because it was the last theory that we studied, and it is having like it's the most correct story, most correct that till now that has been given theory. So,
yes, it does not give any idea of molecular geometry and shape. It's a limitation of MOT.
molecular
Coordination chemistry and coordination compound. What is the purpose of electronic spectra in coordination?
Sir, basically for studying the different type of color complexes or different type of transitions that are occurring in the coordination compounds, we need to have the electronic spectra so that we can predict about the formation, their stability also we can predict from the electronic spectra. And like what are the color that are seen, and I think this much we can explain from the electronic spectra, especially we see. And especially the stability, why the tetrahedral complex is more stable or the octahedral complex is more stable. These are seen by with the help of electronic spectra.
Yes, good. Transition element and lengthenide elements. Which one is more colored?
So sorry, transition elements and lengthenide elements. Okay.
Yes. Which one elements is more colored?
Sir, transition elements are more colored than the lengthenide elements because first thing, there are two reasons. First thing is that the splitting of the energies in the lanthanides are more higher than in the transition elements. Second thing is that the transition metals are having the d orbitals which are inner orbital. but the lanthanides are innermost orbitals. So for the lanthanides, the transitions to occur, they are not having means more intensity or more frequency of having the transitions from lower to excited state that is seen in case of transition elements. So we have more color intensity in the transition metals, but there is one thing that, okay, lanthanide complexes are having a sharp spectra. They are having a sharp peaks, whereas in transition metals, we see broad spectra. So base intensity, especially in the transition metal, is high, but the lanthanides are having sharp spectra, so we can predict the exact wavelengths from where the spectra are occurring, which is not in case of transition metals.
Yes, good. Good explain. Why lanthanide is +3 oxidation is stable?
Yes, sir. Lanthanide +3 complexes are more stable because for the lanthanides to begin with, it is having 5d1 and 6s2 configuration. So if it loses the 3 electrons, it gets the stable complexes. So which are having only F electrons. So lanthanide 3+ complex is more stable than the other oxidation states because it gets a noble gas configuration. Lanthanide 3+.
Yes, good. Actinides. Why not +3 oxidation state is not more stable? What the reason?
I don't remember the reason, but I think for the actinides to have the +3 oxidation state, they might have been stable, but with the increase in the means with the increase in the 4f orbital, they are having first thing the higher Z effective. Second thing, the most of the actinides are radioactive elements, so we can't have a specific oxidation state for the radioactive elements, especially because they are unstable in nature. So I think these can be one reason, but I don't remember actually.
Lanthanide, actinide is 5F, I think. Yes.
Yes, sir.
4F is lanthanide and 5F is actinides because size increases. Yes.
Okay, for 5f, they can easily lose their electrons respective of the 4f because 4f is inner orbital and it is more closer to the nucleus. So it will have more Z effective as compared to the actinides. So
Yes.
actinides can variable oxidation state as compared to lanthanides. Yes, okay.
What is reaction mechanism in inorganic chemistry?
The reaction mechanism is a concept which explains the reaction, which how it is happening. Means basically when there are electron donation, electron acceptations, removal of leaving groups, so all those by an arrow and push mechanism, if we show these in the steps, then we call it as a reaction mechanism. And basically it also explains the type of reaction which is happening, like it's a nucleophilic substitution, nucleophilic addition, electrophilic substitution. So these are the things which comes in the reaction mechanism. Is what are the type of reactions and how they are occurring. These are the 2 points which I.
Yes, 2 types of reaction mechanism in organic, like thermodynamic stability, kinetic stability. What is the difference with these?
Okay. Thermodynamic stability basically means the stability of the compound is more. Like it is thermodynamically more stable. So whichever the compound is more stable, we call it as a thermodynamic more stable. But the kinetic stability means the formation of the product is very fast. So whatever the product that is formed fast, we call it as a kinetic product or kinetic stable product.
Yes. Yes, good to explain. Next question. What is the difference between tetrahedral, octahedral, and square planar complexes?
Okay, sir, the tetrahedral, octahedral, and square planar complexes are having different geometries. As from the name, the tetrahedral is having tetrahedral geometry in which the 4 ligands are attached in a tetrahedral and the metal is at the center. And in octahedral complexes, there are 6 ligands surrounding the metal in a octahedral positions, all at 90-degree angles, forming the bonds with the metal. And in square planar complexes, they are all the four ligands are in a plane surrounding the metal atom in a square. Basically, the formation of these metal complexes are having their splitting of d orbitals in different energies. Like in tetrahedral, we are having a splitting where the axial orbitals are below the energy level, below energy level, and the non-axial orbitals are above, like d z square and dx square minus y square are more stable, and dxy, dyz, and dxz are less stable. In octahedral complexes, we see the reverse order because the ligands are coming axially, ligands are at the axial positions. So dz square and dx square minus y square are higher in energy, while the non-axial dxy, dyz, and dxz are in lower energy. And in case of the square planar complexes, we further see the splitting. As in case of octahedral complex, we can say that, okay, if the two ligands at the opposite positions are removed, then we get a square planar complex. So there is a further stability of the z along the z plane. So we are having a splitting of orbitals in like dxz, dyz, then we are having dxy orbital, then dz square orbital, and dx square minus y square orbital. So basically, these are the differences between the square.
Yes, good. Why tetra?
That,
yes, yes.
yeah, if we say based on the stability, then we say that square planar complexes are more stable than the octahedral complexes and then the tetrahedral complexes.
Yes. Why tetrahedral complex is always high spin?
Okay, sir, because the energy difference between the splitting orbitals is so low that the pairing energy that is required for the formation of the pairing of the two electrons is much higher than the splitting energy. So they always try to prefer the means having non-paired electrons rather than the pairing, because the amount of energy required is more in the case of pairing.
Yes, good. EDTA is a pentadentate, a hexadentate ligand. EDTA.
Hexadentate ligand. Hexadentate ligand. It has 6 donor sites. 4 from the acetate ion and 2 from the amine, means NH molecule, N molecule, not NH.
Yes. What is the difference between hydrate isomerism and linkage?
Okay, sir, hydrate isomerism is a type of isomerism shown by the solvent molecules when the solvent is water, like when they are having different hydration, like different hydrate molecules, like if cobalt NH3 dot 6 H2O, cobalt NH3 5 dot 1 H2O dot 5 H2O. So they are having different hydration molecules like 6, 5. So this type of isomerism is called hydrate isomerism. By the linkage isomerism, a type of isomerism shown by the ligands which are having 2 donor sites in it, when it can associate with one donor site and the other one is its isomerism. Like in case of SCN, if it donates from S side and the other isomerism it donates from N side, so these type of isomerism are called linkage isomerism.
Yes, good. यस अच्छा है, आपने बहुत अच्छा एक्सप्लेन किया है, वेल एक्सप्लेन टुडे.
सर एक
यस यस आस्क मी.
सर जैसे अगर हम रिएक्शन मैकेनिज्म बोलते हैं, क्योंकि रिएक्शन मैकेनिज्म काफी लंबा है, काफी खासकर अपन जब एमएससी, इफ वी कंसीडर एमएससी सिलेबस, रिएक्शन मैकेनिज्म इज लार्ज. So it will comprise of SN nucleophilic reactions, electrophilic reactions, and addition reactions, or more they can go for enolate chemistry, because especially my topic is enolate chemistry. I like the enolate chemistry very much, and the formation of reactions and all these things, aldol condensations and all these reactions. So I should go for this or reaction mechanism.
Reaction mechanism is good topic. Reaction mechanism means what is reaction mechanism? How many types of reaction mechanism? Reaction mechanism is 4 types: addition, elimination, substitution, and rearrangement. Addition is 3 types, substitution 3 types, elimination 3 types, rearrangement so many types.
So we can go for broad topic.
Yes, broad topic. Reaction mechanism basics. Basic only reaction mechanism, types and 4 types. It's sufficient in part of reaction.